Hey guys, today we are continuing our talk of acids and bases by talking about a neutralization reaction. So really quick, just a quick review. Acids are those substances that will donate hydrogen. They increase the hydrogen ions in a solution and their pH is less than 7. Bases are the ones that increase hydroxide ions, so anions in solution. Their pH is greater than 7. So strong acid would be a lower pH, strong base would be a higher pH, okay? So now let's jump into these neutralization reactions. So a neutralization reaction is just the reaction of an acid and a base, which is neutralizing the pH, okay? And again, a neutralizing pH would be trying to bring the pH as close to 7 as possible. So what these reactions look like, they are a double replacement reaction. So you're going to have an acid and a base as your reactants, and your products will be a salt and water. Okay, so water is going to be a product. And now the salt is going to be an ionic compound. Remember, ionic compounds are a compound with a metal and a nonmetal. Okay, so let's take a look at some examples of this. So acids will react with the bases in the neutralization reaction. Salt and water are always the product. So basically what you're learning today, or what you need to know today, is that an acid and base will be the reactant, and then salt and water will be the product. Okay, and you'll have to be able to identify a neutralization reaction by looking at it. So I'm going to show you a few examples here. So here we have HCl, which is hydrochloric acid, plus sodium hydroxide will yield sodium chloride plus water. Okay, this is a neutralization reaction. Okay, we have our acid, we have our base, then we have our salt, which is sodium chloride, and we have our water, which is H2O. So remember that neutralization reactions are a double replacement, right? So what's happening here is the sodium and the hydrogen from our two compounds are switching places, right? So now the sodium is going to be bound to the chlorine, and the hydrogen is going to react with the hydroxide to give us water. Okay, so that's a neutralization reaction. Acid plus base gives us salt plus water. It's a double replacement. Here we have sulfuric acid, which is H2SO4. Sodium hydroxide will yield Na2SO4 plus 2 waters. Okay, so that's just a balanced equation. Here again, double replacement. This hydrogen, right, is now going to be with the hydroxide to give us water, and now this sodium is going to be bound with that sulfate, that SO4. So again, same formula. Acid, base, salt, water. And again, the salt is going to be a ionic compound, which is metal, nonmetal, right? And SO4 is a polyatomic ion. And then finally, we have our HNO3, magnesium hydroxide, which will give us our magnesium nitrate and water. Okay, so again, the water, or the hydrogen from the acid, is going to couple with the hydroxide from the base to give us our water. And then it's a double replacement. So for the magnesium, it's just now going to be bound to that nitrate, which is that NO3. So it's just a double replacement reaction, but again, acid plus base will give us a salt and water. Okay, and if a base is neutralizing an acid, again, like with Tums, if you have heartburn, something like that, if you add a base to an acid, what it's working to do is to bring the pH back up to 7, okay, because 7 is neutral. And that's it. You just have to be able to know what a neutralization reaction is and be able to identify one when it happens. Thankfully, the only chemical reaction we're talking about in this unit is a neutralization reaction, so that's the only one you'll have to be able to identify. Okay? If you have any questions, let me know, and if not, you guys are good to move on to your pH lab.